In the previous lecture, we have already seen how we can form partial differential equations by eliminating arbitrary functions. But here, if I have function, for example, I have a function 5 which has two parts. Say the first part is x plus y plus z, and the next part is x square plus y square minus z square. So let's consider the first part as u and the second part as v. So the function phi has two parts, u comma v equal to 0. In such a case, when we have such functions, now how do we find the partial differential equations? Now we have to do that by using the chain rule. So let's see how we have to solve such problems. So we have to partially differentiate this function phi with respect to x. So we have to do this by using the chain rule. So therefore, del phi by del u into del u by del x plus del phi by del v into del v by del x equals 0. Now similarly, partially differentiating the function phi with respect to y, we have del phi by del u, and then differentiate u partially with respect to y plus del phi by del v into del v by del y equal to 0. Now take this term to the RHS. So you have del phi by del u into del u by del x equals minus here del phi by del v into del v by del x. Call this as equation 1. Now again take this to RHS. So we have del phi by del u into del u by del y equals minus del phi by del v into del v by del y. Call this as equation 2. Now in such problems, we have to do this using chain rule. Now the easier way is divide 1 in 2. Divide 1 by 2. So if I perform equation 1 by equation 2, what happens? Del phi by del u gets cancelled. Minus sign del phi by del v also gets cancelled. So we have del u by del x divided by del u by del y equals del v by del x divided by del v by del y. So for all such problems, we just have to perform this. Partially differentiate u with respect to x divided by partially differentiate u with respect to y, and equate it to partially differentiate v with respect to x divided by partially differentiate v with respect to y. So let me write this. So we have del u by del x divided by del u by del y equals del v by del x divided by del v by del y. And of course, we assume that del z by del x equals p and del z by del y equals q. This is for easy representation. So now let us solve this problem. So u is x plus y plus z. So what is del u by del x? Partially differentiate u with respect to x. So you get 1 plus del z by del x. So therefore, del u by del x is equal to 1 plus p. So where p is del z by del x. Similarly, partially differentiate u with respect to y. So you have del u by del y equals 1 plus del z by del y, which is q. Now partially differentiate v with respect to x. So del v by del x equals 2x minus 2z del z by del x, which is p, and partially differentiate v with respect to y, which is 2y minus 2z del z by del y, which is q. Now then we have to use this relation del u by del x divided by del u by del y equals, so what is del u by del x? It is 1 plus p divided by del u by del y is 1 plus q equals, taking 2 common outside, you have 2 into x minus zp divided by 2 into y minus zq. So 2 gets cancelled. So now let's cross multiply 1 plus p into y minus zq. So 1 into this term is y minus zq. P into these two terms is plus py minus zpq equals multiply 1 plus q with this term. So 1 with these two is x minus zp. Now multiply q with x, which is plus qx, and multiply q with this, which is going to be minus zpq. So minus zpq gets cancelled. So let's bring all the p and q terms to one side. So we have py and this is p here. So when it comes to LHS, it becomes plus zp, and then you have minus zq, and then you have, when this comes to LHS, it becomes minus xq equals x. Take y to the other side, minus y. So taking p common, you have y plus z minus q into x plus z equals x minus y, where p and q are defined by del z by del x and del z by del y. So this is the required partial differential equation. Next problem, consider function x into y by z, comma z equal to 0. So let u be equal to x into y by z, and let v be equal to z. Right? So therefore, to form the partial differential equation, we have to use this expression which we have already seen in the previous example. So what is del u by del x? So what is del u by del x? Partially differentiate this with respect to x. So you have y by z into differential of x is 1 minus xy into differential of 1 by z is minus 1 by z square into del z by del x, which is p. So take y common, we have 1 by z minus xp by z square. So if I take z square common here in the denominator, so I have z square, so you get z minus xp. So this is del u by del x. Now partially differentiating u with respect to y, so del u by del y equals x by z minus, so similarly here we have xy by z square q. So now take x common and similarly take z square here in the denominators, you get z minus yq. Next, partially differentiate v with respect to x. So what is del v by del x? It is nothing but del z by del x, which is p, and del v by del y is nothing but del z by del y, which is q. So now we have to perform this. So del u by del x is this term. So you have y into z minus xp by z square divided by del u by del y is this term, x into z minus yq divided by z square equals p by q. Right? So z square gets cancelled, cross multiply, x goes here, y comes here. So this gives z minus xp divided by z minus yq equals xp divided by yq. So now cross multiply, you have xp into z minus yq equals yq into z minus xp. So this is the required partial differential equation. So next problem, I have a function f where you have x square plus 2yz and y square plus 2zx. So this is equal to u and this is equal to v. Right? So again we need to find del u by del x and so on. So u equals x square plus 2yz and v equals y square plus 2xz. So what is del u by del x? It is 2x plus 2y, del z by del x is p. So similarly, what is del u by del y? You have 2 y into del z by del y, which is q, plus z. Next, what is del v by del x? So it's equal to, of course, this is 0. You have 2 into x into del z by del x is p plus z. And what is del v by del y? It is 2y plus 2x del z by del y, which is q. So again perform del u by del x divided by del u by del y, and so on. So you have 2 into x plus yp. So del u by del x divided by del u by del y should be equal to del v by del x divided by del v by del y. So you have 2 into x plus yp divided by 2 into y cube plus z equals 2 into xp plus z divided by 2 into y plus x cube. So 2 gets cancelled. So now let me cross multiply. So multiply this with this. So x into these two, you have xy plus x square q plus y square p plus x q yp equals, multiply these two. So xq into these two terms. So you get yqxp plus yq into z is yqz. Then z into these two terms. So you have plus xpz plus z square. So these two terms get cancelled. So bring all the terms with p and q to one side and the remaining terms to the other side. So you have y square p, and then you have here minus xzp, and then plus x square q minus yzq equals z square, and take this term to the other side, you get minus xy. So take p common, y square minus xz into p plus x square minus yz into q is equal to z square minus xy. So this is the required partial differential equation. So this is how we form the partial differential equations, by eliminating the arbitrary functions, wherein we have to apply the chain rule, where you have the given function f, which is itself dependent on u and v. So we have to apply the chain rule. When we apply the chain rule, we get this result. Using this, del u by del x divided by del u by del y equal to del v by del x divided by del v by del y. Using this, we can obtain the required partial differential equation. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And to view all the other videos related to partial differential equations, the links have been given in the description. So do not forget to view them, and thanks for watching.